All right, so quick review of properties. We have the commutative property. So when I hear the commutative property, I think of commuting, and I think of kids, older brothers or sisters commuting back and forth to college. That means the numbers are going back and forth. When you look at the first example where it says addition, you have 5x plus 4, and notice the numbers kind of like switch places. They go back and forth there. So you have 4 plus 5x. With multiplication, notice the numbers are like being moved around. So the commutative property allows me to move numbers around through addition and multiplication, meaning order doesn't matter too much. So like 2 plus 3 is the same thing as 3 plus 2. And same thing with multiplication. 2 times 3 is the same thing as 3 times 2. Now the associative property, when I hear of that, I think of my associates, the people I work with, my group, my work group. And grouping in mathematics is parentheses. So with the associative property, we have 4x plus 2 in parentheses plus 7x. Well, that equals 4x plus, in parentheses, 2x plus 7. So notice the parentheses are moving, okay? That means, like, when I add numbers, I can kind of group them in a way that makes sense to me. I can use these two properties in combination. And I'll do that a lot with you guys. It's the same thing with multiplication there. The identity property, when I think of my identity, it's who I am. So I'm trying to get back to who I am. So with addition, okay, whenever I add 0 to something, I get back my number, what I started with. That's the identity. So the additive identity is 0. And the multiplicative identity is 1. That means whenever I multiply something by 1, I get back that thing. Now, the reciprocal of a number. The reciprocal of a number that's non-zero, because you can't divide by 0, is just 1 over that thing. For example, 4, well, the reciprocal is 1/4. Okay, if the number was 2/3, the reciprocal would be 3 over 2. You just kind of flip it. Now, the addition property of equality just means whatever I do to one side, I have to do to the other. So I can kind of undo things as long as I do the same thing to both sides. So for example, if I'm trying to solve x minus 2 equals 10, I think we can all figure out that x equals 12, because 12 minus 2 is 10. But how do I mathematically prove that? Well, if I add 2 to both sides, my minus 2 and plus 2 cancel. And then on the other side, I have 10 plus 2, and that's my 12. Likewise, with subtraction, I can subtract the same thing from both sides. So if I have x plus 2 equals 10, well, I think we can see 8 plus 2 is 10, okay? But if I want to prove that, well, I can subtract 2 from both sides. And you can see my plus 2, minus 2, they're going to cancel. They're going to add up to 0. And I have 10 minus 2, which is 8. I can also do this with multiplication and division. So in essence, whatever you do to one side, you have to do the other, okay? And you're going to undo things by doing the opposite. Meaning, if I'm trying to undo addition, I'm going to use subtraction. If I'm trying to undo multiplication, I'm going to use division, okay? So let's turn the page. And this property is very useful. It doesn't seem useful, but it is. Okay, so this is the distributive property. Now, if I ask Nate, you there, buddy?
Yeah.
Nate, if I gave you a big stack of papers, like in class, like say a bunch of packets, and I said distribute it, what would you do with those packets?
Give them out to people equally.
That's exactly what we're doing here. Okay, mathematicians don't try to be like sneaky with things. They just try to be upfront. So the distributive property means I'm just going to pass that number out to everything inside the parentheses. Okay? So if we look at the expression right here, right there, 3 times the quantity of x plus 2. Well, what I'm going to do is I'm going to distribute that 3 inside. So notice the 3 goes to the x and the 3 goes to the 2. Okay? So that's how I use it. Now, it's very useful with the area formula, okay? So that's right here, and we can show that later on when we're multiplying two polynomials. But distributive property just means pass that number out to everything inside. All right, because I'm a teacher that likes to give you guys choice, Drew, you there? Drew? No bueno? Oh, Drew, 1, 2, 3, or 4. Which one would you like me to do as an example?
2.
2. So if I'm doing problem number 2 and I want to use the distributive property, I'm going to start by drawing my arrows. So that 6 is going to go to the x. So 6 times x is 6x. 6 times 9 is 54. And that problem is over. Mackenzie, you pick a problem. Which one do you want me to do? 1, 3, or 4 now?
4.
Perfect. Now with 4, it's a little tricky because I have this -2. But I'm still going to do it the same way. I'm going to distribute that -2 to each of those. So -2 times 8w. I'm just going to do -2 times 8, that's -16. And then w comes along, okay? Because -2 times 8w is just -16w. Now -2 times -3, well, negative times a negative is a positive, so 2 times 3 is 6. Now, I want you guys to do 1 and 3. 1 and 3, real quick. All right, here we go. For number 1, that's pretty straightforward. It's like number 2. We're just going to distribute that 4 inside. So we have 4y, and we're going to add to it 4 times 3, which is 12. Was everybody able to get that one?
Yeah.
Good. Now, number 3 might look harder, but it's not. We just distribute the 5 3 times. So 5 times 4 is 20, so 20m. 5 times -3n is -15n. And 5 times -1 is -5. So that's the distributive property. All right? Now, all on your own, no help from me, okay? And I'm going to pick on 4 of you to do it. And once we're done these 4 problems, we're done for the day. All right, so hurry up and get them done. I'm going to give you guys like 2 minutes And then we'll go from there. All right, here we go. Let's do number 1. Kevin, can you help me out with number 1?
Negative 3x plus 15.
Perfect. Negative 3x plus 15. Sophia Phillips, what did you get for number 2?
Negative 10y minus 25.
Negative 10y minus 25. Sophia Kender, what did you get for number 3?
12x minus 24y plus 42.
Perfect. And last but not least, let's go with AJ Quay. What'd you got?
I got 16 minus 8n.
Perfect.